Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give a few examples related to the application of Poisson distribution. And we're going to start off with this simple example right here. So we have 2% of the books bound at a certain bindery have defective bindings. Determine the probability that 5 out of 400 books bound by this bindery will have defective bindings. And clearly, this is a binomial experiment where you can see that success is defined as have defective bindings, having defective bindings. So success is have defective bindings. And the probability of that is 2%, which is 0.02. Next, you can imagine that each book will be checked to see whether it is defective or not. So the results are two outcomes, defective or not defective. And the book is checked one by one after another until up to 400 books. So here n is 400, and the probability that 5 will have defective bindings. So here we've got the number of success. So here x is equal to 5. So we're going to find out what's the probability of getting 5 successes out of this 400 number of trials. So one way of doing this is, of course, you can apply binomial formula, or another way is you can apply Poisson formula. Now, why can we apply this? Because I've already talked about the idea of when n gets to a large number, then we can use the Poisson approximation to binomial. The rule of thumb is that n has to be like greater or equal to 20, and the probability is small, like maybe less than or equal to 0.05. And based on this example here, we have checked these two boxes here in order for us to use the Poisson formula. Okay. Now let me just start this example here by using or by applying the binomial formula first. Therefore, probability of getting x equals to 5 is going to be nx. Okay, this is what you have to do. So this is the formula. I'm just writing down the formula right here. So n is 400, x is 5, p is 0.025, 1 minus p is 0.98, this one is 395, and if you punch in the values into your calculator, you should be able to get the result is 0.0911. So that is using the binomial approach. Next, we are going to apply the Poisson formula. So probability x equals to 5 is going to be written in this manner. We're going to apply this formula, lambda x, x factorial e negative lambda. So what is lambda? Lambda is equal to n times p. N is 400, p is 0.02. So lambda here is going to be equal to 8. And we're just going to apply that directly here in this formula. So we have 8, x is 5, 5 factorial, e negative 8. And if you plug in these values into your calculator, punch in these values, you will get 0.0916. And you can see there's similarity between these two results that we've got here, maybe just a slight discrepancy. So that is the approach of using Poisson approximation to binomial. Okay. Now, in the next example here, this example here is also similar to this one, the previous one. Of course, you can either use the binomial formula, or you can also resort to the resort to using Poisson formula. And for this example here, I'm just going to stick with using a Poisson formula. And if you want, you can try it on your own. What's the result like if you apply the binomial formula, okay? So here we have records showing that the probability is 0.00005 that a car will have a flat tire while crossing a certain bridge. So find the probability that among 10,000 cars crossing the bridge, at most 2 will have a flat tire. So therefore, we can see clearly that in this case, success is defined as having a flat tire. Having a flat tire. And the probability of success is 0.00005. And this is such a big number of trials. We have n equals to 10,000, where you keep on checking this car to see whether it has a flat tire or not. So clearly there are two possible outcomes, success and failure, flat tire or no flat tire, yeah. And because this is such a large number of trial and the value of p is small, therefore we can use Poisson approximation to binomial, which means you can apply this formula here, lambda x, x factorial e negative lambda, where lambda is going to be equal to n times p. So what is n times p? Well, n times p is 10,000 times with this value here, you will get 0.5. So that is our lambda. Okay, now let's look at how we can solve this. So the question is asking us to find at most 2 will have a flat tire. So finding the probability that at most 2 will have a flat tire. So when you talk about at most, that means the number cannot go more than 2. So if you want to translate that into a mathematical statement, that means you're talking about the value of x being less than or equal to 2. And this means we need to find what's the probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. And you have to add all those probabilities. Okay, so that's what we're going to do. Now we're going to just apply this formula here with different x. Okay, so here we have lambda is 0.5, x is 0 factorial, e negative 0.5. Now plus this is 0 actually, so 0.5, 1 factorial, e negative 0.5. Next plus 0.5 to the power squared 2 factorial, e negative 0.5. And of course you can see that this term here is similar, where you can just factor it out. So we're going to factor that out, e negative 0.5. Now what happened to this term? 0.5 to the power of 0 is 1, 0 factorial is 1, so the result here is 1. Plus this one here becomes 0.5, and this one here is 0.5 square root 2 factorial, which is actually equals to 2. Okay, 2 factorial is just 2. And you can punch in the values into your calculator and you should be able to get this result. Excuse me. Right, now let us move on to the next example here. This is an example where Poisson formula is applied to describe the number of successes in a certain time interval. So here we have the average number of trucks arriving on any one day. So this is an example of time interval, and you talk about the average number is known to be 12. So average number to be known to be 12. This is the value of lambda. So here lambda is equal to 12. And the question is asking you to find what's the probability that on a given day, so you see a given day, one day, so it matches, yeah? On a given day, the number of trucks arrives is between 9 and 11. So what it is asking you to find is what's the probability number of trucks is between 9 and 11, and this can be mathematically translated by representing the number of trucks arriving as a random variable. So x here is the number of trucks arriving, so that is our random variable, and clearly that this random variable has a Poisson distribution. And here we can say that what's the probability that x is between 11 and 9. Okay, so that's what the question is asking you to find, and this is the same thing as finding the probability x equals 9, probability x equals 10, and probability x equals 11. And we are just going to apply this formula straight away. The formula that we need to apply is lambda x factorial e negative lambda, and we're going to just change the values of x, right? Okay, so here we've got lambda is 12, x is 9, 9 factorial e negative 12, plus 12, 10, 10 factorial e negative 12, plus 12, 11, 11 factorial e negative 12. And of course, you can simplify the look by factoring e negative 12 out of this. So we can factor that out. So we have e negative 12, 12 to the power of 9, 9 factorial. Next, we have this term and final term. And if you punch in these values into your calculator, the answer that you should get is 0.3066. Now, let's say that we twist the question slightly. Let's say that the question is asking you, instead of on a given day, let's say that the question is asking you what's the probability that in half a day, on half a day, the number of trucks arrives is between 9 and 11, so half a day. Therefore, when you talk about the time interval of half a day, your lambda is no longer 12, because 12 here represents the average number of trucks on any one day. So if you talk about half a day, that means your lambda has to be equal to 6. Okay, it makes sense because 12 in a day. Therefore, if you're asking for probability that the number of trucks arrives on that half a day period, therefore lambda is 6. Well, if the probability is asking, if the question is asking you to find the probability that on a given week, the number of trucks arrives is blah blah blah. So if you talk about on a given week, that means lambda here 12, because 12 represents the average number in one day. So if you talk about 1 week, that means 12 has to be multiplied with 7 days. So lambda is going to be 84. So just bear in mind that you have to adjust lambda accordingly to what the question is actually asking you to find. So you have to look at the interval or the region asked by, by this statement here. What's the probability in that particular time interval? Okay. All right, I think that's all for now. Thank you very much for watching.